Good evening, guys. My name is Derivation. I'll be taking us through the derivation of the Fourier coefficient, where we have our f of t to be a naught plus an cos omega not nt and bn sin omega not nt. So I'll suppose to derive our Fourier coefficient here. Now in this video, follow me through. I'll take you the steps one after the other. Now to get the Fourier coefficient for our a naught, let's start. So we are expected to take the integral for both sides, for both the left hand side and the right hand side. So we are going to have our interval. Our interval is going to be from what? From 0 to t. So I'm going to have the interval of this from 0 to t, which is going to be my f of t dt. You understand? Then I'll take this one also from 0 to t. So that's going to be a naught of t dt plus the integral of this 0 to t of what? Of an cos omega not n dt. The integral of this also. So we have this from 0 to t bn sin omega naught n of t. So this one dt, sorry, omega naught t, sorry dt. Now when looking at this, when you take the integral of this side and the integral of this side, both sides equate. Both sides will equate to 0. So you're going to be left with this side. So when you're going to be left with this side. So we take the integral, so we write this back from 0 to t. We have our f. So we have f of t dt equals to, definitely we already know that we have our a naught. So we know that the integral of dt will give us what? T. So we're going to have this from what? From 0 to t. So definitely what are going to be left with here? We're going to have our what? A naught. We are going to have what? A naught dot t. So we divide both sides with t. So we're going to have a naught be equals to what? 1 over t, to bracket from what? From 0 to t dot f of t dt. So we've gotten our Fourier coefficient for what? For a naught. Now let's look for our Fourier coefficient for bn. Now to get the Fourier coefficient for bn, we are expected to multiply through with cos omega naught nt. Are you getting it now? Now the reason why you're going to do it like this is to make sure that what, at the end of the day, we are going to be left with only what? Our Fourier coefficient for what? For an. So let's do that. Let's multiply both sides by what? By cos omega naught nt. So multiplying through with what? Cos omega naught nt, we are going to have our f of t dot cos omega naught nt. Okay, sorry. Let's multiply through with cos omega what? Nt. So, but for this kind of condition, our m will be equals to what? Our m will be equals to what? To n. Are you getting what I'm saying now? So you're going to have a naught cos omega naught mt plus an dot, okay, so I'm going to have what? Cos square. Don't forget that we see that what? Our m is equals to what? Equals to n. We are going to have cos square omega naught nt plus b. Sorry, can you see it clearly? I guess so. I'm going to have plus bn an sine dot cos omega naught nt as the next step here. So the next step here is this: we are expected to take the integral of both sides. So I'll take the integral of this to get the value of our an for you. So you are going to do the rest for your what? For your bn. Now let's take the integral of both sides. You are going to have this. Don't forget our interval. Our interval still remains the same, which is going to be from 0 to what? To capital letter T of what? Of f of t cos omega naught nt. So you're going to have this integral from 0 to t a naught cos omega naught what? Cos omega naught nt plus r. So that's going to be what? Our a n dot cos square omega naught nt plus, so our interval still remains the same, 0 to t. We are going to have bn sine cos omega naught nt. Okay, now when you integrate this, you are going to have 0 be your answer here. For this also, you are going to have 0. You are going to have this. Now let's, because of our time, let's fast forward a little bit. So from here, you are going to take the integral. Let's continue here. So you are going to have from 0 to t, you are going to have f of t cos omega naught nt. So let's integrate. So our a subscript n is our what? Is our coefficient here. So I'm going to have cos square omega naught what? Nt from 0 to t. 0 to t. Now, according to our trigonometry identity, we have cos square x. That's going to be what? 1 over 2 plus what? Plus cos 2x plus cos 2x over t. So when we have cos square omega naught what? Omega naught nt, we are going to have what? Omega naught nt over 2 plus cos 2 omega naught nt over what? Over 2. So let's put this into our what? Let's put this into our integral that we have here. So let's proceed. So we are going to have what here? Our interval is going to be from 0 to what? To capital letter T. We are going to have f of t cos omega naught nt. Cos omega naught nt is equals to our a subscript n from 0 to capital letter T. We are going to have what? Omega naught nt over 2 plus cos 2 omega naught nt over 2. So dt. Now let's integrate with respect to t. We are going to have a subscript. We are going to have a subscript n. Don't forget, when you integrate this, what are you going to have? You are going to have omega naught nt over omega naught n multiplied by 2 plus, when you integrate this, what are you going to have? You're going to have sine 2 omega naught nt over 4 omega naught n. So our interval is from 0 to t. Interval is from 0 to t. Now let's continue with our integration. Don't forget that our omega is always what? 2 pi over what? 2 pi over t. That's for with respect to our period in this particular problem. Now let's treat it one after the other. Now let's go. Now in this place, we assume that n equals to what? N equals to m is always equals to what? 1. So naturally, we already know that what? Our n. We already know that our n is equals to what? 1. Are you following me? So let's come back here. So we're going to have what? We are going to have an an dot this. So I'm going to have 2 pi over t dot what? Dot small letter t over what? Over 4 pi over 4 pi over capital letter t, sorry. 4 pi over capital letter t over capital letter t. We already know our n is 1 already, right? So we already know that our n is 1. So we're going to have from 0 to t. Now, so anyway, we see small letter t, what are we expected to put in there? Our capital letter t. So we're going to have an into bracket 2 pi over t dot t, sorry, dot t over 4 pi over what? 4 pi over t. T cancel t. What are you going to have? Then we are going to have an dot our 2 pi over 4 pi over what? Over t. Are you still with me? Okay, let's do our mathematics here. What do you have here? We have our half. Okay, let's simplify the fraction to get our an. Sorry, you already know that we have what? Sign here. You already know that our sign, for example, we already know that sine 360 will give us what? 0. Sine 180, sine 8 will also give us what? 0. So that was one of the reasons why I said okay. So we already know that this side is going to equate to what? It will equate to what? To 0. So let's go, man. So let's go. So this is actually the same thing as saying 2 pi over 1 over 4 pi over t. So we're going to have a dot n into bracket. So let's go. So that's going to be a dot n into bracket 2 pi t over 4 pi. Pi cancel pi, 2 cancel 2. So what are we going to have left here? We're going to have an, okay. Sorry, please. We're going to have an to bracket t over 2. So let's open our bracket. We're going to have an dot t over 2. Now don't forget that we have this to be equal to this. We have this to be equal to this. So we're going to have from our 0 to t is to have f of t cos omega naught t. So let's divide through with t over 2. So when we divide through with t over 2, we are going to have this. So we are going to have our Fourier coefficients for a subscript n to be equal to what? 2 over t dot from 0 to t, okay, what? Our f of t. So our f of t cos omega naught n t. Thank you. I believe that with this, if we can do well to what? To follow these same steps or follow the process, you should be able to solve for the Fourier coefficient of b subscript n. Thank you for watching. You can do well to what? To subscribe to my YouTube channel. I'm new here. Thank you. My name is Derivation of Fourier.